This is Sunday, the last Sunday in July of 2025, and over here you'll see something entitled The Conjugate Order. This is named after David Bohm's famous breakthrough in quantum mechanics to the metaphysical side, the Implicate Order. That is actually the title of one of his books, and he's recommended reading, although David Bohm is definitely a top-notch mathematician, and quite frankly, they speak a different language, so it's difficult reading. His most famous book, and his first, is Quantum Theory, which is about 600 pages long, but the only readable part of it to a mortal such as you or myself is the first part, the introduction, really the preface as he calls it. Introduction, preface, prologue, these are somewhat synonymous, although they have specific meanings. Now in that mercifully brief preface, David Bohm constitutes for us the very best and only really good summation of quantum mechanics for a mortal. Quantum mechanics is beyond the ken of our most powerful minds, of whom David Bohm is certainly one of the top. He admitted it, Dirac admitted it, Einstein was forced to admit it. They all admit it to one degree or another, except, of course, for Niels Bohr, who never admitted a frickin' thing, for which he got a posthumous Nobel Prize in effect. Now to go to the good side, the positive side, the side that you and I want, progressive science. We are in the synthetic stage, both in the general situation of science. It does not realize that it is in the synthetic stage because it is not human. Now, you and I are human. We are in the synthetic stage right here and now. And this intends to be the full synthesis of science at this time, at the cutting edge, progressive, synthetic, solution-oriented. I will now give you the solution. It's 125 years overdue, but we had a slight interruption in science because of general relativity. That stopped science, that halted science. You don't have to accept that, but if you don't, it won't matter, because what I just said is the absolute truth. Science is stymied. It shows in psychosis, scientific psychosis. So that's the downside. This is the enantiodromia, which is a Jungian term. At the top of the page, you'll see highlighted, this is called the Conjugate Order. That is the title of this brief video, where now I'm going to read this for you because
I know that a lot of my viewers view my videos on their cell phone, where this would not be very legible, very readable.
But don't worry, I'm going to be going through this line by line. There are only about 16 lines. That should suffice to outline our approach to what I discovered. I am a discovery scientist. I discovered a new geometry which turns out to be the oldest and most original geometry of all. Nowhere in science is this known or even surmised. It has to do with the true line. This is going to sound a little bit spooky. I hope if you weren't already expectant of spookiness, you are fully aware that that's exactly what Einstein said this was going to be. It's spooky. So when I say the true line, whenever you use the adjective qualifier true, you're going into Lulu land. Because of course, Western science already knows what's true. So whatever I say is true is going to contradict the establishment. And that makes it, by definition, spooky. So when I say the true line, I am referring to two things. To put this into perspective, a necessary step in any scientific discourse is to state the obvious, to bring us all to the same level, where we all can agree. That means Euclid. So we're going to talk briefly about the line and the circle. The circle is either a line or it's not. That is the beginning of the spookiness. Is the circle a line? Is the circle a line? No. But we need to state why it is not a line. It is because they have different characteristics. You could say that the circle is a line for this reason. You can draw it on a plane. And so you could say that that means it's a line because you can draw it. But that's where the similarity ends. The best way, for the sake of your own mind, to realize the difference fully, so that you know the difference. The Euclidean line is open. This is the only way to begin. So we state axiomatically, the straight line is open. There's a synonymous way of stating that that's much better. This straight line has no surface. Switch to the circle now. The circle is closed. It has a surface. Why can you say that? Can you prove that? You certainly can, without any mathematics at all. Using pure geometric visualization, the closed line has an interior and an exterior. That makes 3 geometric spaces. The interior is one space. These are called subspaces of the enclosing or embedding space. So you have the plane, which is non-parameterized. It does not have an x-axis. It does not have a y-axis. I did that backwards, but that's all right. What it has is an infinite surface. It's infinite, and so it's not a surface. So that's the beginning of the spookiness of the plane. How do you visualize the plane? We know from physiology it's a circle. Because from your center of vision, the plane, and you actually do see a flat surface planar image. It's physiological. We're blueprinted to see that way. The reason we see depth is because of motion, but we'll get there. You probably already know that. But the circle is defined as the center of vision extended in a straight line. It's not a contradiction, it's an integration. This is an infinitesimal part of this, because the straight line goes out polarically. It goes out on a polarity, right? That makes it straight, because each of the 2 rays, how can you characterize these 2 rays? They're symmetric on the center. All right, that should be obvious. That's already known, so you should accept that. So that's the nature of the open line. It's polarized on plus minus, and that is used for charge, for instance. So that is the nature of the straight open line. The closed line has an interior and an exterior. That's equivalent to left and right. But it's not left and right. It's in and out. Sorry. Out and in is a straight line in circular space. That should be obvious. All right, so that takes care of the first bulleted item below line and circle relativity. Euclid defined the line. How is the line related to the circle? Here's the simplest way to see that. As you draw a straight line and the 2 rays come out, it's making an expanding circle, correct? That's called the diameter of the circle. If you go on just one ray to positive infinity, it's still making a circle. Correct? Okay. So you see that. So that's the relationship between the straight line and the closed line. The open line and the circle. Okay. Now that we have used up about 10 minutes of our limited amount of time together for this video, which I try to keep brief, it's difficult to do, but forgive me, we are trying to be complete. I am in the synthetic stage of the completion of my paper, which will be delivered to consensual science through open sources very shortly, within a month. On the next line down, we have physical orthogonality. That's what I discovered. But I'm not the first discoverer of physical orthogonality. What is orthogonality? Let's be obvious. You have one straight line going up. You have a normal to that line is what it's called in mathematics. A normal to this line is the perpendicular line. We have two words for perpendicularity. The best word, technically, is ortho. Not perpendic, but ortho. They're orthogonal. Right angle. 90 degrees. Half of polarity. That's profound. That's what you're going to see directly, is the relationship between openness and conjugality. Conjugality is the mathematic term for orthogonality. That's already known. You may not know that, but you will know it shortly if you don't. If you already do, forgive me, but we need to be sure we're all on the same page, because science, correctly presented, is for all ages. All ages, with a footnote, because youth regresses backwards in time to where there's a threshold where you're simply incapable of understanding what's being said because you don't know language well enough to understand it. But talking about adults, an adult can be at any age, depends on their level of understanding capacity. All right, so that's our introduction to physical orthogonality. We have two examples of that, both of which were discovered within the past century and a half. The first one, the first example of physical orthogonality, which is quite a profound thing to say, because does this occur in nature? You could say yes, you could say no. If you say either one, you're incompletely correct and incompletely incorrect, because it's superpositional. Because this is polarity, this is orthogonality, but you can see that they overlap on a plane. That is incredibly profound. We're getting there. I have campfire smoke poisoning in my lungs, so I do have to hack now and then. Usually I catch it, but sometimes it's spontaneous. I'm on several kinds of medication to prolong my life. All right, the first example of physical orthogonality is the relationship between two fields. What is a field? We'll get to that, but you probably already know. If you don't worry. But a field really is something that is not a point. It's a force field, like magnetism. Does electricity create a field? It certainly does. James Clerk Maxwell proved that in the second half of the 1800s. He proved that the electroforce field is a spherical field, and the magnetic field is also a spherical field, but because they never occur alone, they have a permanent geometric relationship. They are, in fact, orthogonal. So that is the nature of electrodynamics. It's based on physical orthogonality. In the electromagnetic fields, we find two manifestations of this ortho relationship. That's a good word to know. How did we discover that? How did James discover that? Well, he didn't know about the atomic shells, but he did know about electroforce. Faraday had discovered electroforce, the beginning of the crescendo of the Industrial Revolution was based on the discoveries of Michael Faraday, who referred directly and reverently to his predecessor, making this a unique relationship between two scientists. He cited for his insights Roger Josip Bošković, who lived about a century before Michael Faraday, who did experiments proving that electroforce is related to magnetism. All right? You probably know that. Forgive me if you already know that, but we need to be sure we're all on the same page for the breakthrough insights which I will now impart to you directly. Shortly after Michael Faraday came James Clerk Maxwell, who capitalized on the discoveries of Faraday based on the discoveries of Bošković, and he proved the orthogonality of the two fields. There are two fields that are always related. They never occur alone, although there's a footnote for gravity that has not yet been discovered in physical science. After Maxwell died at an uncommonly early age from stomach cancer in his 40s, a tremendous loss. Shortly after that, due to the breakthrough insights of Bolyai and Lobachevsky, a man named Minkowski discovered 4D space, which had no application, but Minkowski was superseded by Albert Einstein, who discovered a use for hyperbolic geometry, 4D, imaginary space. From that, Einstein was able to make several deductions, including one of the greatest breakthroughs in the history of mathematical science. Einstein discovered that space, when it is composed of three lines called 3D linear space, if you add a fourth orthogonal line, which has to be imaginary, obviously, you can prove that time, linearized time would be the right way to say that, linearized time is orthogonal to linearized space. Linearized is the key word because he got a derivative solution using hypercalculus. All right, now we're in the 20th century at the same time that Einstein was making these breakthrough discoveries. Men such as Thomson, J.J. Thomson, were trying to figure out the atom, which had not been discovered yet. The first part of the atom to be discovered was the electron, and very shortly thereafter, the proton. And then a man named Niels Bohr had a breakthrough insight where he found the orthogonality between the proton and the electron. He himself did not know that. He did not know that he had made a breakthrough in geometry. That's what I'm going to divulge to you today. To this day, in electrodynamics in every university course, the word orthogonality is breezed over as if it didn't matter. That's because your modern scientists have lost track of geometry. So this is superpositional. Every man stands, not on the shoulders of his predecessors, but on their database. So inside the atom, what Bohr discovered, you have spheric shells that are quantized. What are they quantized on? The proton core. The center of the atom is a sphere. I have been talking about the circle because it's a planar object. But in volume space, that circle becomes a sphere, and they are directly mathematically related on a constant relationship. So whenever you talk about the sphere, you're talking about the circle. And now you know that the circle is directly related to the line on a constant called tau, which you know as 2 pi. That's the second discovery of orthogonality in physical space. I'll now show you a third. Because the straight line in linear space has no surface but the radial line, which is the integral of the straight line. It's the circular version of the very tiny surfaceless 1D line. When you make that a planar line, it's a force. It's a force that expands the circle. So the radius of the circle is the infinitesimal of the radial force. That is provable. I proved it. But it was really already known. So now you have the true line. It's not this line. It's the volume line. From a sphere, that is either centrifugal force, which goes out, or centripetal force that goes in. All right, so now we have a clear vision of the sphere. It is a surface in physical space that has an exterior and an interior. It's a spheric line. So I give it a new name, so it still has the word line, because this is what the open line is derived from. It's derived from a closed line. This line goes out and stops at the surface. You can think of the line coming in as centripetal force going toward the center. That also stops at the surface, but not in gravity. In electrodynamics it does, but in gravity it doesn't. And that will lead to the direct solution for Einstein's unified field theory. This will be the unified field solution that unites gravity with electrodynamics. I will dispel the boogeyman of calculus and the boogeyman of complex algebra. You will not need them any longer because I've removed the singularity from the 2,500-year-old Bronze Age linear system, which has now crippled science. I am the healer. Blessed be heaven, who gave this to me. Don't look at me, look at my source. Thank you. I told you there will be religion from now on in every one of my video presentations so that you finally understand what religion is all about. This did not come from me. It came from the universe. I will receive no reward from you, but I expect to receive whatever I deserve from heaven, and so will you. All right, there's your warning from Islam. Praise be to the Most High, who blesses us with insight. So the atomic shells are concentric spherical shells which are quantized so that electrons occupy those shells. What is an electron? Pure motion. Pure angular momentum. Very little to do with space, but they exist in space, don't they? This is how they exist in space. How does an electron exist in space if it's pure motion? That's called the quantum paradox. I solved it. You're going to see it directly right now. So what is the answer to the quantum paradox? It begins by realizing that Euclid misdefined the point and he misdefined the line. So both of his axiomata as the basis of scientific linear geometry are absolutely incorrect with a footnote. We had to do that first. There's really nothing wrong in that sense. Because linearity gives us the one component number system, which we have used to this day. One component numbers. Obvious. And now we're done with the obvious, and now we go into Lulu Land, where you may be affrighted, You may feel you're losing your mind. Get used to that. This is reality. The shells are concentric spheres that are quantized. What's the center? The center is where the electrons stop and the protons begin. The protons are always at the center. Now, for simplicity, isolate one proton. That is the center of our physical system, a proton. What is it? It is a force field. It is called the magnetoforce field. Magnetoforce field. That is incorrect. That is incomplete. Ruger Josef Bošković proved that a proton has two force fields. The one pressuring out the straight line in spherical space is a pressure with a radius. That is the boundary of the proton. Incorrect. No, it's not the boundary of the proton. Then what is the boundary of the proton? The electron defines the boundary of the proton. If you have one electron and one proton, they make an orthogonal relationship. Here's how. Nobody has ever seen this. So buckle your frickin' buckle and pay attention with your visual perceptual space. I will show this to you in diagrams in forthcoming video lectures. I've already done so, but you'll never watch them. I don't hold that against you. I was just practicing. But I've already shown you. But you're going to see it now using your mind. And that's the objective here. This is a pressure line. It's not the infinitesimal line of Euclid. It's the integral line of reality. That is half of the proton. The centrifugal force that makes a position. So the center is the infinitesimal of the pressure. And the pressure of centrifugal force creates the proton. The electron shows us that because when an electron is attracted to a proton, it comes in and then goes at a right angle and orbits the proton. So the electron is orthogonal to the centrifugal force field of the proton. The electron is a force field. The proton is a force field. And so this is the intersection of the electroforce and the magnetoforce. That is called simplex hydrogen. 99.9% of the universe, rounded off, is simplex hydrogen. Okay, let's go on. The atomic force line goes out with centrifugal spherical linear pressure. That is spherical pressure. It's not linear, but it is a integral line. It goes out from the center and stops at a fixed radius throughout the universe. That is the quantum of gravity. Magnetoforce never occurs without electroforce. Hydrogen proves that. It's the orthogonal relationship between electroforce, which is a surface at the surface of the proton. So the proton makes a surface in space that the electroforce occupies, making that the intersection of two domains. They're not dimensions because that's a linear concept. This is the spherical equivalent of dimensionality If that doesn't blow your mind, it will. Let's go on. Beyond the radius of the centrifugal force is centripetal force that attracts the electron. If that doesn't confuse you, it should. It will. You will need to become confused in order for you to reorganize your mind in consonance with physical reality. That's the goal of science, is for you to do that. My job is to force you to do that because you can't argue with reality. If you do, you're psychotic. You would be a modern physicist if you argued with that. Let's go on. So the next bulleted item that is in bold is called physical linearity. Does linearity exist in physical space? It does. And it is the ultimate mind blower because now we're talking about the universe as a unit. What does the universe look like at macro scale? Well, in order to know what that is, you have to go out and out and out to see the structure, correct? Of course, that's called astronomy. It's also called astrophysics, if you can make relational sense out of what you see. The first thing we see is the moon, which is a sphere. The next thing we see is the sun, speaking historically, which is also a sphere that's on fire. And then we see the planets in between. All of them are spheres. The planets go in circular orbits, actually elliptical, as was proved by Kepler and finalized in mathematical form by Newton until Einstein came along. That's a summary of history. And so we know that everything in the universe at macro scale in solar system space is spheres and circles. Spheres going in circles around each other. That's monopolar gravity. It's a monopole which makes no sense. That's why gravity to this day is completely not understood. It just cannot be understood because it violates Newton's conservation law. Emmy Noether came along, and she was a contemporary of Einstein, whom Einstein admired. So do I hope you do too. She almost got a Nobel Prize, but alas, she was a woman. Madame Curie, I believe, got 2 Nobel Prizes, but that's because she discovered radioactivity. Much more important to the federal government of whatever country. So, Noether simply discovered something much more important, but it was geometry, and it didn't lead to a nuclear weapon, so she was sidelined as a woman of no account, except to Einstein and me, and hopefully you. What did Emmy discover? She discovered something beyond Newton, the symmetry of conservation. Wherever you have a symmetrical relationship in physical space, there is a conservation law that applies, and vice versa. Whenever you have a conservation law, you have a symmetry. When you apply that to spherical space, you have a symmetry between centrifugal force and centripetal force. In the case of centripetal force, when it's the atom, there's a conjugation between the electron and the proton. They operate orthogonally to each other, as was also proved by Maxwell. Non-polaric, non-Coulomb, non-plus minus, non-charge. Orthogonal, but in spheric space, which you now understand, or rewind this and listen to it again. Now, to go on. Since gravity makes no sense, and nobody's been able to figure out why it can't be understood, let me give you the secret to gravity. When you have a lot of protons, as in the Earth or the Sun, or we'll just say the Earth or the Sun, the bodies that are formed, such as a planet, or the Moon, or the Sun, end up spherical, macroscale objects because of the integration of protonic force. The proton has a centripetal force, although it creates itself with centrifugal force to have a position beyond the range of its centrifugal force, the force inverts. It inverts at the surface to be centripetal. That's conservation. So nothing is wrong there. But with gravity, you're screwed, because there is no conjugation of gravity. I will now show you what is the conjugation of gravity that will give you the force dynamical system of universal reference space that solves everything in physics. Nothing less than that. There's a much longer story after that, because then the funnel opens up into reality. Right now, science is like this. It cannot get to the fulcrum. I got it. So this is the turning point of science itself. And that's enough. In the next video lecture, I'll go on and show you the polyhedral web, which is polyhedral, that's linear, and cosmic jets that form galaxies and stars, that's linear. And then we'll go on to the conjugation of infinity, one of my greatest discoveries in a long list of superlative discoveries that opens up the realm of physical science to rational logic. Keep looking up. We'll be right back today with the greatest video presentation of science in the history of science. Thank you very much for tuning in. I will get nothing from this. You should get everything. We'll be right back. Thank you very much.